machine learning library. He was the creator of it. Like R in Auckland University. Now, DataOps, just a very quick one. DataOps is not a technology solution. I just want to get that very, very clear. Nor is it DevOps, because it's a different discussion. It's a business discussion, but it's really the collaboration of different teams. It's about DevOps engineers, data engineers, and data scientists coming together on a single vision and delivering things in an iterative manner, okay, at a very high level. Just wanted to re-explain that because a lot of people think it's a technology solution. It might be like something on AWS or Azure. No, that's one part of the entire DataOps framework. Cool. Now, with that, I'm going to stop, and I'm actually going to hand it over to Jen. So I've known Jen for a couple of years now. So Jen's, you're the product director at Orion Health. So she's been leading the project with Pieter. Both of them will be talking today, and I believe Anna is also going to be chatting today. So if you guys don't mind doing a quick intro too.
Yeah, no worries. So I think we probably just, actually I'll do the intros now. So I'm a product director looking after some data-driven products here at Orion Health. Pieter's a senior data science consultant, so we work very, very closely together. She's been key in the stakeholder engagement throughout this initiative, which I'll get onto shortly, and Anna's one of our senior software engineers who's actually helped deliver the platform that we'll be talking about shortly as well. So without further ado, I will swap over. And I'll just do a quick check, make sure there's nothing coming up on the Zoom there. Can't see any comments or issues, so I think we're good to keep going. Okay, so National New Zealand Algorithm Hub. So it came about earlier this year when we were starting to, I guess, feel the presence of the COVID-19 pandemic here in New Zealand. So the Ministry of Business, Innovation and Employment, I forgot the last one there. So MB, they released a fund called the COVID-19 Innovation Acceleration Fund, which we applied to and were luckily successful. And what we pitched to them was this 6-month initiative to deliver this national algorithm hub for New Zealand. And we're actually just closing out the last month at the moment. And so what is it? Well, at its core, the first thing we do is, or we're looking to do, is provide a repository or a central place to store algorithms and models. And that's useful in the sense of keeping the visibility of them, versioning of them. You know, we've spoken to organisations, district health boards here in New Zealand that don't have a good grasp or sense of all of the different models and algorithms and calculations and things that they might be using because they're all in little disparate places and they don't have this good visibility of it. So first and foremost, that's one of the key things we do. The next thing we're looking to do with it is enable those models and algorithms to be used operationally. So that's the other core purpose of the platform, is making them accessible, more accessible, and the ability to embed them or use them within a workflow. And the reason that we want to do that, the why, is we often hear about successful data science projects. We often see a lot of, really good statistics, outcomes, predictive ability coming out of these initiatives. However, what you don't always see is the translation of that work all the way through to real world use. And I think that's particularly a risk in healthcare because there's actually a lot of, additional barriers or challenges that need to be overcome when you're looking to get a machine learning model or algorithm used within a healthcare setting. And so the benefits that we're looking to deliver with this is really about, number one, ensuring that the content, the algorithms and models on the platform that we make available are equitable And Peter will talk a little bit more about this shortly in terms of our governance process. The other thing I think is really important and actually quite exciting is we've got this opportunity. So we've set up this single national instance in New Zealand. We've got a process for onboarding content. And what I think is really exciting about it is, we've got this chance to build up this central knowledge base of validated algorithms and models, put them all in one place and make them accessible for use. And, we talk a lot in healthcare around reduction and duplication of effort. And so I think this is a really good opportunity for us to do something in that space, particularly in the adoption of new data science research. And from a data scientist or researcher perspective, so those people who might be creating algorithms and models, the benefits for them is really what we can provide with that platform is the ability for their work to be adopted quickly. It decouples the need for them to worry about the technology. How are they going to support? How are they going to get their new model or algorithm actually used out there in the world? There's a lot of researchers and other outfits that are really great at doing all that business understanding and building the algorithm or model, but they might not have the access to the same resources that we do from a product perspective, scalability, security, all of those things. So that's what we see that we bring to the table with the solution. The hub itself, so we provide 3 interaction channels with it. So there's a website, which I'll show you in a minute. We also have the ability for someone to interact with a deployed algorithm or model on demand via REST APIs. So that could be another application wanting to make use of it as part of a workflow. And we also provide bulk processing capability. And that can be useful in the sense of potentially, say, processing a batch of patients overnight. That's actually a use case we have at the moment. So after day 1 of their hospital stay, we gather up a batch of patients and send it off for processing so that their prediction scores are ready by day 2 of their hospital stay. And so the website. So I'm actually just going to step out of this PowerPoint for now, and we'll have a little look at it. So this is live. We actually just went live on Monday, so that was very exciting. The culmination of 6 months worth of effort. I think we're having a mini celebration tomorrow, which we're all looking forward to. So what you can see here is the hub website, and first of all, you get to see all of the content on it. So these are all of the algorithms, models. We've also got some simple health-related calculators deployed on here as well. So anyone can come in here and just have a look at what's accessible first of all. For certain models, you'll see some of these have a learn more and some have a try out option. And in some cases, it made sense to make certain models and algorithms interactable via the website, but in other cases, it really didn't. And that could either be for the sense of appropriateness. So you might actually want to have a conversation with someone and make sure they understand how to use the model properly before they actually make use of it. And in other cases, it's down to the number of data inputs actually, because we're providing the ability to interact via a web form. So anything that's expecting high numbers of manual inputs, we didn't really make sense to make usable via the website. And so what we'll do here is we'll just drill into one of our COVID-19 models. So I think, again, Peter will touch on this a little bit after me, but early on in the pandemic, Te Pūnaha Masitini, which is a complex systems research organisation, so they did a lot of work supporting the government in COVID-19 disease spread. So helping us understand once we actually knew that we were having outbreaks in New Zealand, what actually might happen from a disease spread perspective and what we might need to plan for. And we actually supported them with running some of the daily reporting, and they've kindly agreed as contributors to enable us to make this model accessible via the hub for others to use. And so what I can do here, before I use the model, what I can do is come in and have a look at it. I can understand a little bit about it, who created it. If it was a model created based on a data set. This is where I can come and find out what data set it was based on, you know, what proportion of the population. These are really important things to understand when I'm thinking about making use of something and its applicability, whether it's got broad applicability or not. And then when I'm ready to use it, or I want to have a little look, I can come over to the try it out option here as well. And what this model does is it effectively runs a number of different simulations and then kind of averages those results out and provides a graphical view of the disease spread. And these parameters here are what you use to set the conditions of the scenario. So there's some obvious stuff here like population size. So we might enter the population for all of New Zealand, our total ICU bed capacity, when we want the simulation to start from. And then we can come into here and actually set some additional parameters around the disease reproduction number, and also what sort of control measures or lockdown or distancing. So what sort of measures are we applying to try and reduce or stem the spread of the disease as well. And so once I've set all the criteria here for my simulation, I can submit it through. And what I get back here is a graphical representation of all of those different simulations that have been run. And now I can see, you know, from the start date, what actually might happen over time from a disease spread perspective when it comes to daily reported cases, admissions to ICU, and also I can see what might happen once those control measures or those measures to help try and prevent the spread of disease, does that actually help to impact these things over time? You see this scenario isn't looking quite so good. Cool, and I think that's it from me. I'll hand over to Pieter now, who'll just give us a little bit more background around the governance and model selection process. Here we go.
Thanks, Jen. Hi, everyone. It's crazy presenting to a room of real people this year.
Half and half.
Yeah, and all our Zoom attendees. So I just want to talk you through, I guess, the user engagement and process we went through to find use cases and get them deployed on the hub. And so this, just a diagram here that shows we started off by identifying high-value COVID-specific use cases. By talking to end users who are people like DHBs, clinicians, local and national government agencies, as well as model contributors who are looking to increase the reach and ease of access to the models that they're developing. So that includes universities as well as private companies who are developing models and algorithms. And then the first step is we would put together what we called a model card. And this is based on a couple of research papers came out in 2019 about effective ways to summarize and present the information about a model. And this went to our governance group that I'll tell you about in a minute, essentially as a first sort of triage step, if you like, to give us an endorsement to proceed to the next phase of governance, or that we needed to go back and do a bit more work. So once we went through that first phase, we then went to a long form algorithm information request. And this was a document that we pulled together based on a number of different local and international guidelines for safe and effective algorithms. And there's so much out there that's at quite a high level. And then when you need the next level of granular detail to actually do this in practice and write the document, it's quite challenging. So we were drawing on quite a few different resources and putting that together ourselves. And our governance group helped us refine and further develop that for applicability here in New Zealand. So we landed on quite a good document that we're really pleased provided a comprehensive model overview. And so for each model, we'd fill that out in detail, put it to the governance group, and have quite a robust discussion with them about the model, its intended use, the risks and benefits, and again, either endorsement to proceed or perhaps not proceed. And when that happened, it was typically because the model wasn't deemed suitable and applicable for New Zealand's context. So it doesn't mean it wasn't a good model, it just wasn't necessarily the most appropriate for here. At the same time, we'd get an agreement in place with our model contributors, and then we'd look at developing all the assets we need for our users. So creating the website content that you've just seen an example of. So how do we actually communicate the key recommendations and guidance from the governance group through to our users, actually getting it deployed on the hub that Anna will touch on, user onboarding and support, and making sure we're starting to get lots of good feedback from our users. So this is our governance group. We were really fortunate to have such an amazing group support this initiative. So our chair, Kevin Ross, is our research director at Orion Health. And the group represents all of the different areas that we think are key to safely and effectively using algorithms, particularly in a healthcare context. And so the document I mentioned earlier aligned with all of these areas, and each of the members on our group really brought the perspective that you'll see under their name to the discussion. And yeah, it was an amazing process. There were a lot of really challenging and difficult discussions, and for us it surfaced a lot of issues where we're able to reach, I think, a position where we actually have some really good frameworks and principles for us to apply going forward. Here's the list of content that we have either currently available on the hub or in the pipeline. So you'll see that we've got COVID spread and effects stochastic model and the SEIR model that many of you will be familiar with. Another use case when we think about supporting New Zealand's COVID-19 response is also supporting organisations to respond to the significant backlog that has resulted from COVID-19. So this includes how do we efficiently schedule, how do we automate activities, and how do we help support prioritisation. So there's 3 examples there. The top one, NZ Risk, for example, looks at pre-operative surgical mortality risk. And it's a tool to support patients and clinicians to have a conversation about whether or not to proceed with surgery. And that came about through a research project that was funded by Precision Driven Health, and it looked at evaluating tools developed in the UK on our New Zealand population and found that the performance wasn't as good as we'd like it to be. So that sparked a research project to develop a new model, which was ultimately published in the British Medical Journal, and we think is a really good candidate for use here in New Zealand. We've also got some COVID-19 preparedness algorithms. So we're in a fortunate position now where we're not seeing large numbers of cases in the healthcare system, but we think it's critical to ensure that models and algorithms identified through systematic reviews of literature and work that's being done overseas are available for use here should we need them, and that we've gone through a good process to assess their suitability for New Zealand. We've also got a number of standard health calculators and tools, and these are more rules-based than predictive models, but we see those as a good part of a comprehensive toolkit for a clinical user. So Jen mentioned earlier the COVID-19 disease spread example. So this was based on Tupuna Matatini's research, and what we were able to do through the deployed models was deliver standardized outputs to a range of different users. So while the research teams were focused on continuous model development as the situation evolved, we were using this to produce a daily national report, as well as local reporting for district health boards, as well as providing raw data for technical end users who wanted to be able to plug that into their own tools and planning processes. So here's an example of what that looked like at a district health board level. So we could use quite sophisticated modelling to produce something standardised that could be used as a fortnightly input to their own processes. Now hand back to Jen.
This is just me, just briefly. And look, I guess just to touch on where we really want to go with this. So we've shown you the website, but we also really want to see this being used as part of clinical and operational workflows. And so this is just a little example this is actually our clinical portal product, which many district health boards here in New Zealand use. If you get admitted to hospital, they might need to look you up, your summary of your information, and many, if not all, use this as their view to see what's going on with you. And it's a little bit hard to see up on the screen there, but we've got this little panel. So this is an interpretable risk score. So the other thing, I guess, and I know Anna's going to touch on this briefly soon too, the other thing we're able to do with these models and predictions is include interpretability, which we also know is extremely important in terms of helping inform decisions, because you don't just want to tell someone that a patient is high risk of something. They want to know what are the factors that were actually driving that risk to be high, because we could get a high score for 2 patients, but the factors driving that risk might actually be quite different. So this is where we're going with it basically, and you know, we're having a lot of really good discussions with different health organisations around how we can take the hub further forward and deliver this sort of capability in future. And I think on that note, Anna's turn. She's going to give you a little bit of a technical flavour of things.
Thanks, Jen. So I'm just going to touch a little bit more on the technical side of things and talk about how we operationalize the machine learning models that we were given and to work with through this project. So we've been trusted as the runtime and host of a bunch of these COVID machine learning models. So I'm going to talk about how with sorting out technology, we can operate these models ethically and safely. So, this obviously comes with quite a lot of challenges. So I'm going to talk through a few of the challenges that we encountered in running this project. So you guys may know there is always new machine learning technologies coming out on the market, and it is a very, very fast-paced and fast-moving environment. So there is a lot of pressure to always stay on the cutting edge and have those tools available for our data scientists to be able to be used. And what we don't want is that to be detrimental to us being able to deliver. We really want to be able to empower the data scientists to use these new tools without any technology or platforms getting in the way. Similar to that, there's a lot of pressure to support machine learning integrations and applications. Again, there's just many things popping up that people have integrated with or want to be able to use in their workflows, and we don't want that to stop us from being able to deliver, which all leads into that fast changing technology landscape, specifically for that data science use cases. Something that we encountered quite a lot through this Algorithm Hub project was a lot of bespoke machine learning solutions. So what I mean there is we've got a lot of machine learning solutions being brought to us and wanted to be put on the hub, but we have specific application use cases baked into the machine learning model itself. So a big challenge for us was to be able to pull out the actual focus on the algorithm and the logic and separate that out from any business application use cases so we could run it in our environment and integrate that in. So that was quite a big challenge, is being able to identify what part here is the monitorable, scalable, versionable model and what part of this is actually business logic. And that was quite a big focus for us in terms of onboarding these new models that came from many different providers. And finally, I'll get a little bit more into this, but another challenge that we've encountered in working with a lot of machine learning at Orion is that machine learning models have a very different life cycle to traditional software. So we really have to make sure that we are handling that life cycle in its own specialized way and not trying to integrate that into our software development life cycle so we can really keep them separate. I'll touch a little bit more about that soon. So I'm going to talk a little bit about our approach to how we handled a lot of these challenges. On the left of this diagram, we have our asset management. So this is all of the artifacts that come from data science creation of models. So this is to support data scientists on their steps. So they have when you're training a model, you've got a bunch of artifacts that come out of that. You have your source code that runs the model and all those assets. So we have all of that asset management on one side of our platform for them to store all of those assets there. So a really big driver of this is to enable data scientists to be able to self-serve themselves with tooling. So we provide DSL tooling for these subject matter experts to be able to define and deploy their own models. So we really put that back into the hands of the people who create these models to be able to manage them and version them as they expect to. So then on the other side of the diagram, we've got our runtime environment, and this is separate to the environment of our asset management. And this is because we really want to focus on, this is where the DevOps people and the software engineers kind of run these models and scale them and monitor them at a runtime level. So this really allows that separation of, the separation there, so we can have that processing done and handling done at an engineering level. This also, Jen touched on a few of our different interaction channels. So here we can now, with one runtime environment with APIs in front of it, we can then allow a lot of different integrations to these models. Because we've pulled that business logic out, we can really focus on that algorithm, which means we can plug in any integration we would like to the platform. But one example of this is the website that we showed you, and then we have other examples on where we've integrated with DHBs to help them with like workflows. I want to run an algorithm every night or something like that. So this really helps us abstract away the model lifecycle from the software development lifecycle and manage it in one single unified environment. So a little bit more on our deployment view. So the algorithm hub is all built on a microservice environment. We use containers so we can have a modularized and scalable system. In the middle there, we've got all of our services that run the algorithm hub, and you can see that's all surrounded by a lot of other microservices that handle their single responsibilities. So a really big benefit of doing this kind of architecture is that we can scale different components in different ways. So if one model needed scaling up because we intended a very high use of that model, we can scale that model up and handle those requests. However, if we wanted to scale up another part of the system, maybe some APIs, if we're expecting a heavy load on an API, then that also is independently scalable. So we're able to both scale up models and software independently of each other to create that environment. We also have industry standard practices on security and using standard access tools, so securing all of our APIs and access into that system in just the industry standard ways. Another really important part of having of our deployment view of this is monitoring and logging. So we always want to be making sure that we understand how our system's performing and how our models are performing. So we set up a very solid monitoring framework that monitors the underlying platform as well as the models. So over time, we can understand how our system's performing and how users are interacting with it. Cool, so at the beginning, I talked a little bit about the challenge of a model having a very different life cycle to a traditional piece of software. I'm just gonna go a little bit more into that. So a model is really valid. It's based off of a snapshot in time. And that model is trained on some data that was collected at a certain point of time, collected from a certain population of people, collected from a certain geographical region or certain location. And then it also is collected in many different ways. So each of these 4 pieces will make up a data set that you can then train a model on. And this data set can be invalid over time. It was true perhaps maybe last year for this subset of people, but this year with who knows what's going on, a lot of models can get out of date very quickly. And this is a big driver on why we separate out the model lifecycle from the software lifecycle. If we create a new model and train something new, we want to be able to get that into production very quickly without having to update any of the underlying software. And we want to let the subject matter experts, the data scientists, be able to update that themselves using our self-service. So that's kind of the idea around why we have that separation, just because of that different life cycle of the model's life cycle versus the software life cycle. So I think Pietro also touched on this a bit, which is the idea of concept drift. So again, we want to have really solid monitoring on our models so we can detect if things are starting to drift based on what they're originally trained on. So a good example of this is COVID modeling. Perhaps a model that was made in February this year may look quite different to what populations may be doing at this time of year. We've got social distancing and things like that. Data that were at the beginning of the year is not going to be as applicable now. So we need to have things in checks and monitoring in place so we can quickly detect that. And so that's something that we're currently working towards on our roadmap of the algorithm hub. And I also talked about how these clinicians trust us, clinicians and organizations trust us to run this model. And what we want to avoid just putting a number on a screen in front of someone and saying, this is the prediction, without giving any information on how did this prediction get made or what information was included in this prediction. So we did a bit of work into model explainability and interpretations. These can be done at a global or a local level. So when I talk about a global level, that's like a global based on the training population for that model. So you can really, when you take a model, you can explain what features were the most important to making predictions in this model at a population level. Then you can also take that down a bit further. If you have 2 patients and you're putting them through some kind of inferencing system, they could get the exact same result out as perhaps a percentage or something, but very wildly different parameters were being used to make those results. So if all you see is the results, you think these patients are the same, but actually under the hood, it's taken different parameters that have made that prediction. So what we've started to do is when we do make a prediction for a patient, we then return back what were the important factors in making this prediction. And then clinicians can also see that on a screen and align that with their clinical knowledge and expertise on what they've learned. And that really helps them be able to build trust in what we're doing and not just see a number on a screen as an example. So yeah, this all kind of fits together onto Orion's vision of creating individual patients and predictions for patients. And so people receive exactly the right care that they need to receive. I think Jen's going to talk about a bit more of the lessons.
Oh, I think me and Peter might
Double up on this one. Oh. Yeah, so just to sum up, I guess, so we were reflecting on this recently, just in terms of what we think's gone really, really well and what might have been a little bit more challenging in this initiative. I might let you start.
Sure. So that governance process was a really fantastic part of the project. So being able to pull together that group of leading New Zealanders in their respective fields to help us shape and continuously take algorithms through that process was a real highlight. We had really positive support and engagement from everyone we've been speaking to about the concept, both in the health sector and in lots of other sectors. So everyone seems really on board with the concept and sees a clear need for this. It definitely enables a shortcut from research to reality. So the COVID disease spread models, for example, it provides a shortcut from those research groups directly to clinicians or other end users who are looking for access to those kind of models. And then in turn, they can provide feedback directly back to the researchers, such as our parameter values tend to be this, or what about this scenario? Could we use it like this? So that was, I think, really exciting for both parts there. And for us, it's just fantastic to deliver value to lots of different national and regional stakeholders. And we're going through the process now of onboarding new users. So really good.
Yeah, and in terms of challenges, and Anna will laugh at this. I think the 3 of us have been in a room at times, and we've been trying to get on the same page about something, and it's just not quite. We're not quite all speaking the same language. So there's a bit of a lost in translation sometimes, I think, between product to software engineering to data science. And so it's been fine. We've worked our way through it. It's been quite good, but it was definitely challenging at certain times. And as we've already touched on, data science efforts tend to be very, very tailored to the specific scenario that the person's been focused on. And what we're trying to do is deliver something that's productized. And so there's been a little bit of a disconnect, but again, we've been able to work through that and we've found it to be a really good learning experience. In terms of the getting it all the way through to adoption and use, there is of course more processes outside of our processes. So you know, each health organisation needs to go through their own validation and approval processes, and you know, this is kind of new, some of this stuff. So they don't necessarily have all of the structures in place to do that easily or quickly. So that's something we're still working through. Similarly, actually, commercial and IP. So again, this is a little bit new. You know, getting others to contribute content to the hub that we're deploying. You gotta you know, tread carefully and make sure everyone's comfortable that their IP is protected, and that we're all in it for the right reasons, etc. So again, we've worked through that and it's been really good, but it certainly slowed things down at the odd point as we sort of had to figure that out. Again, we touched on, you know, New Zealand's lucky to be in the unique position we are in from a pandemic perspective, and so that led to a bit of a stop-go in terms of you know, whether we're focusing on disease spread modelling or something else, and sort of we had to stop and think about our content strategy and what would make sense to actually make available via the hub, still enabling our pandemic response. So that was an interesting challenge, and I think I've already touched on it really. You know, that there is that maturity leap for some stakeholders into the world of data science and machine learning, and you know, I think we're not quite getting perhaps the level of pull or the ability to identify opportunities where machine learning and data science actually can make a difference, even though they're out there. I think there's still a little bit more perhaps education and communication and sort of everyone getting a little bit comfortable with this new world before we're going to see that real pull. Yeah, and that's it. I'm happy to pause for questions here, and if anyone on the line there would like to ask us any questions, I'm very happy to respond. Maybe I might be a bit shy.
So, congratulations, well done. Great to get to launch. I was interested at the very end about that sort of IP and commercialization. What is the model? Who owns the models? How does that
so because this initiative has been funded by ND, it's government money put towards you know, supporting our pandemic response. The agreement that we have in place is that models made available on the hub as a result of this 6-month initiative will be made available for free for people to use. And so that's something that we've built into the structure of these agreements. We've put a time frame on it, so it's not indefinite. So, you know, for those contributors eventually wanting to make a commercial return, you know, they're not giving it up forever. So that's, I guess, on the use side. And then on the contribution side, yeah, I mean, they own their IP, we own our IP. We're not trying to get hold of anything. So again, we've had what ended up being a fairly simple agreement in place, just making that very, very clear, and that, you know, we would look after their IP, deploy it on the hub, make it available for a certain point in time, at which point we might need to have another conversation and see what comes in future. So, you know, I guess there will be some new commercial challenges or questions to work through in future as we move out of the, you know, models deployed via this initiative. So yeah, so still more ground to be broken there, I think, as well. How big? So what have we got? So we've got. I'll go from the governance. So we had a governance lead, which was Kevin Ross, the chair. You saw the size of the governance group itself. Peter was effectively our stakeholder engagement lead. There was myself as effectively like the PM. We've got Anna, Leah, Mitchell, and Mark was our core engineering team. And then also Laura, who was here with us, she was also helping support the model onboarding and deployment as well.
Super.
Yeah, I mean, core team about what, 6 to 8 of us. Yeah. How much effort to bring a new people on? Well, I think now that we've got the patterns in place, it probably would depend on the model a little bit. You know, you might find something under the hood that might add some challenges, but I don't know. Anna, what do you think? A couple of weeks?
Yeah, I mean, it depends on, there's obviously like a lot of process around getting to the point where we can deploy a model. But if we're talking about the actual deployment piece, it's, you know, we're talking like days to get it into production.
Yeah, the actual effort is days. It's just elapsed time can be a little bit longer when you add in, you know, the back and forth and the signing of agreements and all that kind of stuff. But yeah,
that's also service component. Basically, when you drop it, is it like true self-service, or there's still some manual steps?
So we've kept that self-service capability internal for now. But yeah, it's pretty quick to do if, you know, if we have a model contributor saying, hey, we've made an update, please deploy it. Hour. We might have some people online wanting to say something. I've heard the speaker come on from time to time. Anyone got a question? No.
Has visioning data for training models been important? And if it has, have you got any practices around doing that?
Visioning data. I guess that's a step earlier in our process, really.
Yeah, thank you very much. See you again.
Thank you.
Okay, bye-bye.
Bye-bye.
I think you can.
You can use it.
Yeah, just get that one.
So we're not storing any data on the hub about the algorithms, so that part of it sits more with the model developer and their process as well.
We are actually, we've got other products
Yeah.
in that space, but not for this. I'll do my little plug, but not for this specific initiative. That's kind of pre-deployment. Yeah.
So kind of related to that, model review in terms of what the data, what bias might be present in that data. You talked about it at the beginning, I think.
Yeah.
How much work goes into the review of what models you're using?
So that was a really big part of the governance process, was getting into quite a lot of the detail of that in each case. Working directly with the algorithm contributor where we could. Sometimes those people are super busy overseas. So it was, really, I guess, going through all the detail we could from the publication and the data as it was described, and then assessing the appropriateness. Often there's a recommendation that users obviously continue to monitor that in a new context. That's standard guidance.
Yeah.
How many DHBs are actually using that COVID-19 risk score information that you mentioned within Portal? How many can actually use that?
So none at the moment for that. Yeah, that's our vision.
Sure.
But from the reporting example that Peter showed earlier, was it all of them, or was it?
Yeah, so they were all receiving the standard report, and we've got a few wanting the disease spread out, but either as raw data or other forms to feed into their own processes. Two going through onboarding this week, start using it.
It's a bit of a technical question. So there were so many containers on the screen, and I haven't seen any like familiar brands or something from Google, something from AWS.
So what are the technology?
We run our containers through a container orchestrator. We currently go with Kubernetes, run on AWS, using a managed Kubernetes service. So we're a very small team, so we try and, if someone else is going to manage it, we'll let them do it, so that you can see more of us supporting that many containers and things going on. So yeah, everything's run through Kubernetes or managed AWS services.
And for machine learning services itself, are you using some services from AWS as well?
So no, the core machine learning platform side of things is all microservice written that we've developed, and they all run in Docker containers, and that's so we can really understand and hold that life cycle side of things. Yeah.
Is there any plans to move to Australia also?
Plans to find customers in Australia? Absolutely. Yeah. We would love to repeat this in Australia if we could.
Are you aware of similar initiatives in US or Europe?
US, Europe. Less so, but Peter's on it. She's on an Australian group that
Yeah.
has done kind of the other side of this.
Yeah, so we're certainly aware of other groups who are going through the evaluation process and developing a registry of algorithms. So part of that, I guess, overlaps with our own governance, but we're not aware of another national hub that actually provides the ability to interact with the deployed models.
Cool. All right. Well, that might be us. So I think Akash, you wanted to say
Just yes,
the closing words.
platform.
Awesome. Yeah, we'll hang around. I think we can have a little bit more of a bite to eat. Sorry of those of you on Zoom that missed out on the snacks. But look, I guess do we say thank you to the Zoom attendees now? And yeah, thank you all. And feel free to get in touch via LinkedIn or similar if you have any other questions or knew of any model content that you want to see available on the hub. We'd love to know.
And also big thanks to Ryan Health for funding.
Cool. Yes. Thanks to the corporate credit card for that one. Cheers. All right. Thank you, everyone online. We'll see you later.
Yeah.